Good evening, guys. Today our topic is BAT algorithm. Okay, so you can see here is some image of bat. Here is some image of bats. There is the three types of bats are there in our consider. There is 100 types of 100,000 thousand types of bats are there, but we are generally categorized up to this. This is the micro bat, ghost bat, and your mega bat. You can see this is called your micro bat. Okay, micro bat and ghost bat. This is your micro bat at in your hand, just like your hand. Okay, it is seems look like this, and this is the picture of your ghost bat. Okay, and you can see there is also some ghost bat out there. This is northern side, it is available, and this is the mega bat. Mega bat is much bigger than this. It may be uh, 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 as long as just human hand also. Okay, but our concern is to the algorithm is to working with this microbat. Okay, so this is your microbat you have seen, and now we will go for the bat algorithm. Okay, so this is our bat algorithm. So there are about 1,000 species of bat. So first of all, we have to know something about the bats. So there are about more than about or more than 1,000 species of bat. Okay, so but we are concerning with the microbat bat algorithm. So here we are getting the micro, and which is the main topic of the bat algorithm. Bat algorithm is depends on the echolocation. Okay, so two things we have to know. First one is the microbat and the echolocation. So the bat type, if you divided the bat type, so I want to show you some bat. Look, this is the picture of bat. Again, you can see this is the picture of bat. So this is the ghost bat, this is the mega bat, and this is the micro bat. Yes, this is the micro bat. Okay, this is the micro bat. So if you want to see this, so this bat are three types. First one is micro bat, that is first one I say this is the mega bat. Guys, once again you are joining, so I want to show you some bat so that you can understand. This is our bat algorithm. Okay, so we are concerning about the microbat. Generally in our world, this is a 1,000 of bats are there, but within this they are categorized as per its size. So this you can see, this is the ghost bat, and this is the microbat. Microbat is very small. It is fitted in our palm, and this is this is also microbat. This is the ghost bat, and you can see this is your megabat. But we are not talking about megabat and ghost bat. We are just talking about this type of bat. This is called micro bat. It is fitted in our palm. You can see, it is fitted in our palm. Generally it is 5 gram to 150 grams. Okay, and it is 20 centimeter, sorry, 20 to 25 centimeter is span. This span is 20 to 25 centimeter. Okay, so we are talking about this bat, and we will just going to the bat algorithm. This mega bat, and this is host bat, and this is micro bat. So we are talking about this micro bat. We are talking about this micro bat, and this bat is generally, its size is generally, it is a, what is this size? This is a flying mammals. It is a flying mammals. And it is very small in size, and its length is 2.2 to 11 centimeter, and its wingspan wingspan is 25 centimeter, and its weight is 3 gram to, generally 3 to 5 gram, 5 gram to 150 gram. Okay, so we are talking about this microbat. You have seen this picture, and what are the basic of this bat algorithm? The basics of this bat algorithm is that echolocation. eco Location. Echolocation. What is the echolocation? The say this is your bat. This is your bat. This is your bat, and this, say whenever this bat is, you can see this is your bat. Whenever actually bat couldn't see properly. Okay, it's almost a blind. So whenever some creatures is there, say some creature is there, and maybe mosquito, maybe anything, maybe. Okay, this is the mosquito. Generally mosquitoes are at the most time, it will be the prey of this bat. It will create some echo. It will create some echo, or it will create some sonar sound. Sonar. Whenever it will obstacle, it will get back to here. It will get back to here. I am giving this in the dotted line. In the dotted line, it is get back to here. It is get back to here. Then it will select, yes, this is my object, and this is my object. It will create a distance. Okay, so then it will try to either speed up, either increase its velocity. It is, by doing this, it will just reach to this position. So this position is called relocation position. And relocation means this is due to the echo, and that's why this is called echolocation. Then it may change its frequency. It may, actually, in bat algorithm we are considering this 5 times. This is the frequency x, and this is the frequency f, and then we are going to the position is the xi. Say at that moment this position, so this is the x1 position, this is the distance 1. Now after few moment, it became in this position. or it may be statics, or it may be moved. So in this position, say this is the x2 position, what this is the d2. So we are creating the frequency of this echoing, and then this is the position of the x, and we are going to the loudness, how loud it will be, it will creating its echo. Okay, and another is conditions is that what we are going this is, this is the r is there, and r is, it is the pulse means which amount pulse it is creating. Okay, so f, x, a, and the velocity, in which velocity it will physically move, it is its velocity. Okay, so these five things we are going to considering. So if this bat want to reach this position, maybe this is movable, maybe this is fixed, but it is not considerable, because after few times, whenever we again counting, then it will, distance will be changed, either it is going to here, or it is fixed, or either it is also moving here, or this also moving here. So distance may be changed, but we don't bother of this, is this movement or this movement. Then if it's want to catch this, then need to change this velocity, position, and everything, so that it will reach here. And now the bat can change its frequency, adjust its frequency. Bat can change its loudness, because if it is the far away, then say loudness is high, say this is one, then this creature could not listen to it. But if this come to the near, and then loudness is high, then this creature will be alert, then it will certainly change its position, or it try to flee away. So nearer to it is going to here, it should be decrease its loudness. Okay, so this is something is required. Now we are going to the bat algorithm. Okay, so I think you can understand what is the echolocation. Echolocation means is creating the echo. It will detect what is the distance, then it will adjust its frequency, its position, its loudness, its pulse, and its velocity, and it will change its position. It will come next time here, it will come next time here, it will come next time here. But what is the bat algorithm? Bat algorithm for our case. Say this is our object. Say this is our object. This is our uh, object. Okay, and this is, here is our three bats are there. Here is three bats are there. Okay, here is three bats are there. This is the bat. This is the bat. This is the bat. This is the bat, and here is the bat is there. Here is another bat is there, or so many bats should be there. So this is bat 1, this is bat 2, this is bat 3. We have to select, we have to check at the t1 second which bat is position is the best position. Say this is 5 centimeter, this is 10 centimeter, and this is say 6 centimeter. You can see for the t1 second the position is there, but you have to rank this, which bat can easily reach to this position, because you can see its velocity is very less. Say this is 10, its velocity is 90, and its velocity is say 50. So which will reach after t2 second? After t2 second, you can see, though this is near, this bat one is nearer to this object, but it will not reach to this position. This bat will reach to this position. So next time you can see where is your this is your object, and you can see this bat is this bat is reached to here. This is the bat one. Say this is 3 centimeter is there. Velocity is 10, but it this bat, this is bat 2. Bat 2, because its velocity is 90, and it will reach to the 2 centimeter. And this bat bat 3, it is 50, so it may it will also reach to the 3. So which one is the best one? This is the T2 second. So which one is the best bat one? You have to rank. Yes, this is 2. Bat 2 is the best rank because it will reach this position. So in this way we are optimized which one should be selected and which one should be counted as the best position. Say you have you whenever you go to your computer shop, you have seen so many computers are there, but some screen is 14 inch, some screen is 21, some screen is again 40.5, and this parameter are there. You became puzzled, and some price is also vary, but this is very nearer to each other. Say if this is this is $70 and this is $71 and this is $72. You couldn't understand which one you have to select because this is very nearer to each other, and the categories are not same for each this type. So you have to select which one you have to collect, either this, either this, either this. It is not mean that your $71 goods are very much high than other. It may not be. Maybe that this time this item would be the better. So you have to select. So here is also there. It is seems that it is so far from the subject, but whenever we go for the algorithm, you can see that is after few seconds, after the T2 iteration or the second time, whenever we go for the count, then it will be the nearer to this position. So in this way, we have to select which bat or which bat position is selected. So this phenomenon is converted into the algorithm, and we will fit our any optimization problem. Then we can reach this position, reach the solution. This is the objective of BAT algorithm. Now we are going for the, I think you can understand, and now we are going for the BAT algorithm. What is the statement? And then one by one we solve an problem. Okay, so we are going for the BAT algorithm. Please write it down, this BAT algorithm. Otherwise, it is not available in your general notebook, general internet also. So that is our BAT algorithm. BAT algorithm. That is your BAT algorithm. First of all, we have to initialize the bat population. Means how many bats are there. Side by side, I will give you the note also. Okay, okay. Live guys, just note it down. This is the actually this is the algorithm. Step by step, it will go. Initialize the bat population. Actually, population means how many bats are there. There, bat 1, bat 2, bat 3, up to this. How many bats you have considered, then such amount of calculation you have to go on. So this is bat 1, bat 1, bat at 2, etc. So next position is, this is 1, this is 2, this is algorithm. Okay, this is going on. First you have to initialize, then initialize the frequencies. Analyze the frequencies. That is, if I is something is going to there 1, 2, 3. Actually, there is some limited frequency. Say bat one has maximum and minimum frequency. That is, say this frequency is minimum frequency 5, maximum frequency is 10. This is the bat 1. This bat 2, oh, its frequency is frequency of wave. Okay, frequency of wave. If its frequency is minimum frequency is 3, maximum frequency is 8. Okay, in this way its frequency is there. Sometimes in our question the frequency also initialized, or given, or we have to given it. Okay, or whenever we go for MATLAB program, actually there is no MATLAB program for your theoretical part. But if you go apply this algorithm in your project or in your anywhere, then you have to mention this. Okay, then the next step is the pulse rate, frequency and the pulse rate. Pulse rate, RI. Pulse rate means how much pulse it will creating. Okay, and the loudness, and the loudness, and these are the secondary option. Okay, first we are going to the position, frequency, and our velocity. This is the main things. Okay, then next step is while t greater than this t for iteration means how much you have iterate, means first t1 second, t1 this you have to calculate, then t2 you have arranged this again, update this all parameter, then you can see, then t3 you have seen this. But how much iteration you need, this is the t is the maximum number of iteration. T means, say we are taking the 20 iteration, so whenever it is going to the 20, you have just going this, because bat position are gradually coming to this object. Say this is bat 1, this is for bat 1, this is for bat 2. This position is gradually coming. Look, this is very slow coming. In say this is the bat 3, this is the bat 3. It is fast coming. So you have to take some iteration so that you can get this. Say that is iteration 1, that is iteration 2, second time you have calculate, third time you will calculate, and fourth time you calculate up to 20 iteration. So this is the maximum iteration, maximum number of number of iteration, maximum number of iteration. Okay, if this is one, this is first time t0, yes, initial position, t1 time you have calculated. If up to this, if it is less, then generate new solution by adjusting frequency and velocity and location. So these three things will be changed, and other loudness and the pulse, it will not change first time. It will change if it is required. Okay, if base position is required, then it will only change. Otherwise it will not change. Then if it is updated, then if r random, you have to select a random number, that is 0 to 1. Say this is a 0.2, 0.4, 0.5. We have to select a random number. If this random number is greater than this ri, okay, this pulse, then select a solution among the best solution. Okay, generate a local around the selected best solution. Okay, and then next step, It is the algorithm, it is going on. So it is if random, this is random value we have selected, random value is less than AI, means loudness, and and this is called fitness function. We have to go for another note, which one is the fitness function. This fitness function is, if this is the newly calculated, then this is called fitness. This is fitness function. Okay, this is the fitness function. So you can understand after then you have to check this portion. Whenever you check this, then we can do this. This is the fitness function. And till now it is going on, and just we go for the fitness function. Then if it is satisfied, look here, two conditions are there, means this is a AND gate. If AND gate is there, if there is a AND gate is there, if this is, say this is x condition 1 c1, this is condition 2, if this is 1 and this is 1, then only output will be 1. If any one of this, if this is 0, if say this condition is not satisfied, then this is 0, this is 1, so it will not be 1, this will be the 0. If this is 1 but this is 0, so it will again became the 0. So only whenever this condition A and B, this condition will be satisfied, then we go for the next step. Then accept new condition. Then accept, accept the new solution. What is the new solution? New solution states that it will, if you have to give, and this is left space is there, increase the RI. Increase the RI means pulse rate you have to increase, and then you have to reduce the loudness. Okay, this is the pulse and this is the loud. So after then we have to check which one is best. First one is coming frequency, then it is coming position, then it will coming the velocity, then it will coming the loudness, then it will coming the R. Okay, so say this is for bat one, iteration one, and this much we will get. So then we have to select which one we have to the best solution. If we get this, then yes, all are getter, then we have to select this. So this is the things, and now we have to write for the next step. This is the end step. Okay, then end if rank end if and rank the bat and find the current best position, and then end while. This is if loop, this is while loop. Okay, means we have to again change its position. So first time this was x1, then it is x2, then it is x3. So we have to, this is for bat 1, that 2, that is x1, that is x2, that is, say that is x3, that 3, that is, I'm going to the another color, that is x1, that is x2, that is x3. So after watching this, we have to select which one is the best. Yes, this is the best because this is reach to the nearer to this object. So this is x is the best position. So in this way we can calculate, say our control system, yeah, any other system where optimization is required. Yes, in this way, say three processes are going there: process 1, process 2, process 3. Then in this way, yes, this process is reach this stability very fast. So we have to select it. So in this way, we are resemble with that algorithm toward any optimization system. So this is about your algorithm, but now we have to go for an example. Otherwise, we can't understand what is the algorithm is saying. First, it is the initialization of the bat population, then initialize the frequency. All things are initialization. This is the first thing. First, iteration means first time you have counted, calculate, then second time calculate, then third time calculate. If your ultimate iteration, say I am taking 20 times iteration, say I am taking 10 times iteration. Actually, this optimization and simulation process are going on, so simulation software, under software, so there we can easily do 20 10 30, how many times we required. But actually if we go for the mathematical hand to hand tools, then it is so much time consuming and so much complicated. But in this chapter we have to do perform in your own hand, otherwise we can understand what is the iteration problem. But some functions will be taken from the MATLAB, so that we can easily get this. Okay, so start an example. Okay, and first example we are taking for the BAT algorithm. BAT, it is the example. If we take, say we are taking three bats over there. This is bat one, this is bat one, say this is bat two, this is bat 2, and here is the bat 3, bat 3, and your object is here, your object is here, this is your object. So you can see this is bat 1, this is the position, this is the bat 2 position, this is the bat 3. All bats want to reach this position, but we have to select which bat can, which is the best position of this bat, or which is the best bat, because within this few seconds it may be going here, it may be going here, but it may be changes distance, but which bat can and easily reach this position. Because if I go for the second iteration, this is the second part, then it will change its position, then we can easily find out which bat can easily catch this object. So first we have to initialize which thing. First is frequency. This is just write down frequency. Frequency also create a factor. Then this is given by fi. This is v for velocity. This is velocity. This is a pulse. Pulse is r. R is later on. R is later on. First we have to frequency, and then position. Position that is given by xi, velocity vi, frequency fi, and then we go for loudness, ai for loudness. Then it is come pulse, pulse ri, pulse rate or pulse, whatever you can say. Now what is the frequency? Frequency is the number of waves at the unit time. Okay, how many waves it will create at a time. This is the frequency. Okay, velocity, how much velocity it will occupy to reach this position. This is say this is your x1 position. After few times it will reach here, so this is your x2 position for bat 1. After few times it will reach here, this is your x3 position. So position also change. A1 is the loudness, means how loud, just like your decibel time, how loud it is creating its sonar. Because some of you, or maybe all of you, you have listened whenever bats are creating its echo, or owl are echoing their echo, some sound, some portion of sound are audible to our human ears. You have seen some some chattering sounds are coming from this sound, and this is very less, but actually they are creating ultrasonic, so this is not audible to us, but sometimes we are it. But this creature can also listen with it, or it maybe has some capacity or ability to detect, yes, mm, some enemies are coming there. So it has to update its loudness and pulse rate also. So this is your factor. So we can select the random value of this. Say for bat one, say for the bat one, this is your for bat one. This is first time frequency. You have to frequency, then you have to give some velocity. Velocity, you have to give some position. You have to give some. This is your bat two. Say bat bat 2, this is frequency, this is velocity, this is x, this is position, this is loudness, this is your pulse rate, and this is bat 3, this is bat 3. You have to initialize frequency, velocity, x and a, and this is r. You may put some random value, but within the position. Say your frequency is 2 over there, your frequency is 6 over there. If your frequency is here, you can put this is your 3 frequency. Okay, and no units are required, just we are putting some, assign some numerical value so that we go reach to this. Okay, so this is velocity is 3 and position is 4, position is 4, and your loudness is 1, and this is, these things are 0. This is the pulse. Okay, this is pulse, and this is for the bat 2. This is, say, random, this is 6, this is velocity is 7, x is 8, position is there, loudness is 0.08, and this pulse is 0.2, within 1 and 0. So we are putting this. Frequency is 3, position is, say, 5, velocity is, it is 4, and this is loudness, it is, say, 9, and it is given 0.1. This is an example. We got this. So first time, what we'll do? First, if you see the algorithm tells you initially. So this is the first step one. Step one, it is initialization. Then it will be step two. Step two. Step two. Step two is telling that you have to select the position. Position. So position is x1, x2, and your x3. Okay, x1, x2, x3 you have got. Okay, then step 3, select, you have to going this, and for step 3 you got this iteration. Just remember the iteration. While I am again repeating this, this is the t means iteration is maximum number of iteration. Say your iteration is 10, your iteration is 10, so this is the first iteration. So because this is 1, this is first time you are going, it is initial 10, this is t0, and if you go for the first iteration, so this is the less than 10, so yes, we are going to this way. But whenever it will reach to the 10, 10 is not less than this, then we have to stop. Okay, and iteration is 1. Okay, so now if this condition is true, yes, it is condition is true, then generate new solution. Then generate new solution. Okay, by adjusting frequency, which things we have to adjusting? by adjusting the frequency, and updating the velocity and the position. So these three things I told you first, these three things will be coming to the consideration for the iteration t equal to 1. Then we will select which one is the best. It may be best, it may be best, it may be best. Then we will go for the update of these two things, A and R. Then we will again watch which things are the best. If these things was any of three was best, then we have to go for the solution. So first time we just change these three, don't change these two, just change, because if this bat and this bat, this is one, this is two, this is three, first position, then its second position will be, if this objective here, second position is this one, maybe this one, maybe this one. Okay, so this is one, this is two, this is three, three dashed, two dashed. This is the second position. This is the T1, and the third position. This is the third iteration. It may be reached. It may be reached. It may be here, and it may be here. Okay, so this is the third iteration. This is double dashed. This is double dashed. This is double dashed. So in this way, we have to go for the iteration and we have to choose the best. Yes, after this, look, this position is the best. This bat is best. After this, yes, you have also seen that this position is also best. In this way, we can find it out. Okay, so we have to go there. Now, what are the formula for the updating the frequency? So frequency is first, frequency formula is that frequency minimum f minimum plus f maximum minus f minimum into this beta either 0 or 1. If it is update, then 1. If it is not update, this is 0. So first time bat 1, you have to go for the first time bat 1 iteration 1. Look, first time, just remember, frequency was 2, velocity was, what was the velocity? Velocity was 3 and position was 4, and A is, this time these things are not changeable over here. These things are not changeable over here. This is the iteration. This is T1. This is T0, and whenever we write this, this is T1 for this T1. This is A, this is R. These are the same. This will be same now. It will not change here. So these things will be changed. So frequency will be changed minimum and to the maximum. Say for the bat 1, it will be, this frequency will be given to you in your question. So minimum frequency for bat 1, that is 2, and maximum frequency for the bat 1 is, it is for the 8. This is for the bat at 1. Okay, but this bat can be adjusted within this frequency range, otherwise no. So next frequency is I. The first one is 0, then it will go to the 1, means iteration 1. It will minimum, it is 2, maximum it is 8, again minus minimum, this is 2, beta, yes, it is changing its frequency, then it is 1. So we will get 2 plus, this is 6, this is 8. So we can update over here, this is the 8. Now we have to calculate the velocity. This is velocity. So what is the formula over there? Yes, formula is that VIT, this is IT, I for bat 1, bat 2, bat 3. So this is always 1. So VI, again VI, T minus 1 plus, this is the position, TIT position minus xt, this is the g based into fi. This is the position into frequency plus the previous velocity, because velocity is also changing. First time it is going to normal velocity, normal speed, then again it's increases velocity. So velocity also update. So what will be the update velocity? Updated velocity will be that this is the vt t equal to first time this is the 1 and this is 1. So this is 0. So first initial velocity is 3. So you can see this. mm, This is V1 where for bat 1 this is 1, this is VI, this is 1, and T1 T is 1 minus 1, this is it will be giving 0, and this host velocity best position till now we are not able to find out. This is the first iteration, we don't know which one is the best, so we have to put this 0, and this T is just the initial velocity. So this is 1 and this T was which one? This T1 is your this 4 minus 0, and frequency this is also your first time frequency. What is this? This is T1. If F1 means I means 1. So which will be the frequency? This frequency it became 8. So this is 8. Okay, I frequency. There is no mention that is T or T0, what are the there? There is the I. So in this loop, which frequency is there? Yes, this frequency. So this is Vi minus Vi0. Vi0 is these things. So you have to put over there 3, and this is X10. X10, what which one is? This is 1. This is T means 1. This is iteration 1. So it will be giving you this is the 4, because you can see this is the 4, sorry, this is the 0, this will be the 0 initial frequency here. And ghost the base is not there, so this is 0, so this is 8, and we get this is 3 plus 4 into 8, that will become 32 plus 3 equal to 35. So we have to update it, because velocity we got here, we have to update it, that is the 35. Now you have to select your this X position. X position till now we are not available, so that's why we are writing your this position. So this will be always the T means this is the 0 previous. Okay, so X, now find out the position. Xit is the Xi T minus 1 plus Vit. You can get this is xt. Okay, xt means here is the this position initial. Okay, always initial, because t minus 1 is coming. If you put 1, that minus 1, that will be coming 0. So this is your initial. Previous initial means this is previous, and plus vit. So what is your vi? I is 1. So you have to put that is the 35, and this is t. T means your iteration. Iteration is 1. So your value is, that is x0 value is 4. So 4 plus 35, it will give 39. So you have to update this. This is that is 39. So you have updated. So this is the iteration process, and you have to, this is the ultimate iteration 2 for the bat 1. Same things you have to perform for your the bat 1, bat 2, and bat 3, because you have taken this. So you have to go for the bat 3, bat 2, sorry, bat 2, bat 2, bat 2. Just write it down. Just write it down. What are the back to? Oh, this is the frequency. Frequency was 6. Just remember this thing. Position is x. Velocity is 7. A is your 0.8, and R is your 0.2. That is for the iteration t equal to 0. And we have to calculate it for the iteration 2 for the frequency, for the position, for the velocity, and for the A and the R, these are the fixed. So these are the unchanged for these cases. Now this is, if the others condition is not satisfied, then we have to change it. So this is 8. and this is 0 2. Okay, for this t equal to 2, just we have to know, put this, you know the equation. So guys, if we go for this, then velocity vi I t, this is, you just remember vi t minus 1 plus xi I t minus xt g based into frequency 1 fi. So just putting this value, we are getting vt 1 minus 1, this is 0. So vt, it will giving you 7. So this is 7 plus xit is the x0. Just simply it will say the x0 position, because we don't know this position first. So we have put this 8, and this is the 0. Frequency I means 1. So this is giving you the 7. Okay, it will be updated. I just show you, it is not shown. It will coming 7. Okay, so it will coming, you can it will give you 63. So it will 7. If you calculate it as the formula is given, what is the formula, just remember, frequency is the frequency I is the minimum frequency plus maximum frequency minus minimum frequency into beta equal to 1 or 0. Okay, so if something is given, then you can put it. Okay, say this is the 1 and 7. 1 and 7, it is the frequency range. So minimum is 1 plus, that is 7 minus 1, and that is 1. It is coming 1 plus 6, that is 7. Okay, in this way we can find out. So velocity is 63. Now we have to find out the x. X means position. So xi formula is, just going to the another one. Xi is the position is xi t minus 1 plus vit. Time is very less, but we have to do t for 2, bat 2. Okay, and this is the iteration 1. So put this 2 1 minus 1 plus v2 1. So you have to put this x, this is the x0. What will be the value of the x0? X0 value is the 8. So put this 8. V2 means for the bat 2, for the this item for the bat 2, and I for this is the 1. So we have to put 63, I for 1. So 63, it will coming 71. Just update it, it is 71. So we got this items. This is iteration 1. Just like in this way, if you go for the calculation of bat 3, I'm going to the new slide. If we go for the bat 3, then we bat 3, that 3. Same calculation is there. F is 3, X is 5, and V is 4. A is, it was given 0.9, R is given 0.1. This is the iteration t equal to 0. Now we go for the iteration and t equal to 1, means second step. So what is F, what is X, what is V, what is A, what is R? These are the same. These are the same. So it will not change. Sorry, internet connection is not okay. So if we calculate it, we got this is 5, this is 34, and this is 29. Okay, so this is our updated value. Okay, now we go for the step 5. We go for the step 5. Here we can find out the random value, means which one is the random value. Say this is from 0 to 1. This is the total random value, means within this random value you may scale it. Okay, say this is the 0 0.2, 0.2, this is 0.4, this is 0.6, this is 0.5, this is again 0.6, this is 0.8, this is 0.9, and this is ultimately 1. So you select this 5.5. So 0.5 is the value of rand 0.5. Okay, so you have to check whether you have to check the conditions for the pulse rate. we don't change this. Okay, but now we have to also update this. We just do this for the 3, but these things was remain unchanged. So we have to change this. We have to change this. If but what is the condition? Say for the r1 we have seen this is 0. For the r2 means bat 1, this is the bat 2, this is the bat 3, this is the r3. It was, what was this thing? 0.2, 0.2, this is 0.1. So if you select this random value 5, then you can see all are the greater than, sorry, this is the random value, this is the less than this is the random value, this random value is less than this random value, this is the 0.05, this is the 0.05, this is 0.05 is greater than this is 0.1, so this is random value is 0.5, so greater than this. So it is the true value, it is the true, it is the truth. The conditions is that you can remember this: if random is greater than r1, what is the algorithm? Algorithm is saying that if random value, whatever you have selected, random value is greater than ri, then select a solution among the best, okay, and generate local solution around the best solution, so if you examine this, that is after first iteration means after changing, that is bat 1, that is bat 2, that is bat 3. Look, till now r and a are not changed, but up to this, yes, random value is greater than this, so then between this you have to select any one of these. So f is 8 for bat 1, x is 35, v is 39, a is 1, and r is 0. Here bat 2, f is 7, x is 71, v is v is 63, and a is 0.8, r is 0.2. It was given, a and r was unchanged, till now it was unchanged. F is 5, x is 34, v is 29, and a is 0.9, r is 0.1. Look, you can see by examining this, you can see this frequency is differing from each other. Position is also differing. This position is 71, this position is 35, this position is 34. Velocity is also changing. This velocity is much high. Okay, this velocity is much high. So you can see frequency of the bat 1, frequency greater than bat 1, then bat 2, frequency of bat 2. Okay, so which will be the solution? First you have to check the frequency. Yes, this frequency is high, this frequency is high, so best select the solution among the best solution. Okay, this is called solution. Among this solution we have to get the best. But how could I understand which one is best solution? If prey is in the scope, frequency increase, and frequency of the wave increase if the bat finds the prey. Means if it is a scope, means it is under something, scope is there, means it can visit this, it will visualize or under coming to the area, then we have to change the frequency. Okay, so in this position, what is the best frequency? Best frequency is the this one is the best frequency. So we have to consider on this best frequency. Yes, we have to select this. Then we have to update this position. So if all bats change its frequency up to this, then it will be the certain frequency. So base frequency will be this. Then we have to update the x1. We have to update the x1. So x new means position, x old plus this loudness. Okay, this this things is lies under -1 and 1. If it is going to the negative, then negative. If it is going to the front side, then this is positive. Okay, sometimes it has missed because your position was there, then object was moved and bat is coming, so it will go into the this position, overcome, then again bat has to come in this position, so then it will be the minus. Otherwise, if this position is there and bat is coming same position, then it will be the positive position. So it will be changed as per the requirement. This is old is 35, so we are taking this position. So all these items are taken considered over here. We don't consider this, we don't consider this, because this frequency is better. So frequency is better, so we are taking this. This is one, and this is ultimately this is coming one. You know, this is also loudness is one, this is also one, so this is one. It is up to 36, so its position became 36. It is updated. And next step, if the random value, if the random value rnd random is if random value is less than ai and function of x, this is fitness factor. Fitness factor, in next lecture I will show what is the fitness factor, how it is calculated. Okay, so it is coming over there, that is after calculation it is coming 0.2, so this is coming and it is coming 5, so it is satisfied true. And it is coming random value is 0.5 if I selected, and this is coming 1, so it is also true. If this is true, these things and these things are true, then we accept this solution, else ri and the ai should be ri increased, then increase ri and reduce ai. Okay, if this is satisfied, then we have to increment this. So ultimately what will be the formula of the ri? Ri is that this is first time we are operating this. This is t plus 1 equal to ri into this is 1 minus e to the power gamma, that is t alpha gamma equal to 9 point. It will be given to your problem. Okay, and ai is the t plus 1 equal to alpha ati. So by this we are getting the value of, we can get this value, it will be changed up to this. Okay, so we can update the value of the other things. Say, you can see this is the best solution, that one is the best solution. Okay, but these are, it should be updated. If we update it, then we can get bat 1, bat 2, bat 3. Say, then the loudness is decreased as the bat moves to the close to the prey, and pulse rate emission should be increased. So this is for bat 1, this is for bat 2, this is for bat 3. So this is the f1, this is within the f1. For the bat 1 is the 8, that is x, it is the 36 means position. Then v is 39, in a is, that is the one first best solution, and r is the 0.04. But it will be update. A and b was not base solution, that's why we are getting update. So f is 7 as previous, x is 71 as previous, v is 63 as previous, but this item a is the 0.08 and r is the 0.03. It is updated. It is updated. And b3, it is also, f is the first previous time, x is the 34, v is the 29, and e is the 0.09. It was not updated because it is same. R is the 0.03. It was also updated. Okay, So within this, you can see this the, here everything are the best. So the rank bat one is the best because you can see this is loudness is one. So getter loudness is there, and sorry, pulse is also getter. This is point 3, but it is point 0.4. So this is also better. This is also better. But velocity we don't require because the last solution it is taken on this basis. So these things are the best solution. So this bat one is the best solution. So in this way, we can select the bat one position is the select position. This is the optimization technique. I think guys, after the long session, you have understand this. Otherwise, you can again watch this video. Then you can, I think you can understand these things. Okay, thank you for listening me. This is all about the optimization of belt algorithm, and next class I will again explain the fitness function, how the fitness function, this is fitness function, how it is occupied, I will explain. Okay, then it will be completed. Okay, thank you for the day. Have a nice day. Have a nice day, Ritesh.